So we are going to talk a bit about event sourcing for the coming 45 minutes. And when it's event sourcing, it's very persistent centric. But before we take off, I want to mention a few words about me. My name is Petersson. I work at Squeed as a software consultant, mainly in Java. I like to work full stack. If you want to contact me after the talk or follow me, you can find me at GoToOla at Twitter or olapetersson@squeed.com if you want to mail me. Okay, I work for a company called Squeed, and as you already know, you heard the pitch previously tonight, but I just want to say that we are like the event host and gather Java forum once every quarter, and we are always looking for speakers, or if you want to do something with the Java community in Gothenburg and want to use our forum or platform, please contact me or anybody with a Squeed logo on their clothes. So, by a show of hands, who here is using a relational database manager today? I would say that that's 80 to 85% of the people in this audience. I asked this question to 20 of my fellow Squeed colleagues. 19 out of 20 raised their hand. And I asked the last guy, the one who didn't raise his hand, what do you use? And he just smiled at me and said, we don't use a database. And this is quite interesting, like we are so keen on telling people that there is no silver bullet. Yet, for some reason, we are really buying into relationship databases or RDBMSs. And what we usually do when we work with an RDBMS is that we have our state in some kind of table. Like in this small little web application that I have here. I have a state, and on this state, we can upload it, we can download it, give it +1 or -1 basically, and we just hold the state. And when we do these kind of updates, we do an insert into the database table or maybe an update, and we change this from 50 to 51 to 52. Now, RDBMSs are really powerful. Like they've been proven in a lot of different concepts on a lot of different techniques, and they are really powerful, but they are not like the perfect solution. And one challenge with it is, as Uncle Bob Martin stated in this tweet, that the biggest problem with ORMs, object to relational mappers, is that they don't really map object to relations. Tables are not objects, they never were, and they never will be. And if we look at the table, it's like this flat structure, right? Whilst in our Java code, we have hash maps which holds lists, which holds a list, which holds a list, right? A lot of different data structures. And we as Java developers, we like to use JPA or Hibernate to kind of abstract this away. But Hibernate is kind of a leaky abstraction, meaning that even if we try to abstract away the database, we still have to understand what it's actually doing. Because otherwise we immediately get an optimistic locking exception. Like that happens all the time. Another thing which might not be that obvious to start with is that when we do updates to our data in our tables, we are performing destructive operations. Like, sure, a delete is clearly a destructive operation, but also an update. Because if we have 51 and we update it to 52, we remove the 51, right? So what if we took another approach to how we deal with persistence? Because there is another way to get from 50 to 52. And this is the very basic fundament of event sourcing, where we start with a starting state, 50, and then we add a 1, and then we add a 1, and then we get up to our state, right? And what we really focus on when we are talking about event sourcing, it's the deltas. It's the differences that made us go from a starting state to what we have today. Now, event sourcing is nothing new. I think there was like a software journal published in like the 70s, but it has gained some kind of popularity during the last years, which might be due to the microservice hype and a lot of asynchronous communication today. But when we speak about event sourcing, since it's such an old concept, there has been a few semantics introduced, which I will cover for you here today. So when we speak about event-sourced systems, there is a concept that is called commands. And commands are steering signals into our system. They are intentions, something that we want to do. Add one, like tweet. These kind of operations that we want something, we have an intention to change something in our system. We also have events, which you could hear from the name. It's very centric in event-sourced systems. And events are facts, things that happened, immutable things that we never change. They did happen, and that's how it is. And events are typically, if we have add one and like tweet, the events would be one added and tweet liked. They have happened in the past since. And in an aggregate, or in event sourcing, we also speak about aggregates, which is a component or could be a class, which in the end holds these different changes to our state. This aggregate all the events that has happened into our system and kind of makes sense of it. So how this correlates is that you have a command, you from that command, like add one, generate an event, one added. You then apply this to your current state, or what you currently have, and you produce a new state with this delta added. And if you take a step back, you realize that this is pretty much the functional paradigm, right? So we produce a new immutable state. And we only come in with things from the side, and we generate a new state. And in this case, the aggregate would be the one who holds the state. And everything, or the only thing that we persist in those kinds of systems are the events. That's the only thing that we persist. So let's have an example of how it works. So when me and a couple of my friends goes to Lagom, the waitress comes over to our table, and she asks me, what do I do? What do I want to have? And I like burgers, so I say that my intention is to add a burger. She writes it down and she says, okay, a burger added. And then we add a burger to our order. And I also like beer, so I want to add a beer. An event of type beer added is generated, and we then apply this to our state, our order. And this could go on. I have a healthy friend who wants salad and also water. And now, as I said, the only thing that we are persisting are these events here. And that means that if we ever want to reproduce our state, which is basically why we persist things, we don't want it to be a one-off, we want it to be reproducible. Well, then we go from a totally empty order and we replay these events. We go from an empty order and say burger was added, beer was added, salad was added, and water was added. And then we have rebuilt our state. Could anyone here think or come up with a system which by its domain or by its technique utilizes this kind of approach to build state? Every database? Yeah, pretty much. If you are in the technical domain, I think Git is a very good example. Like, you don't hold your whole data or your whole code base in a reference like in a table. What you do is that you start with an empty repository and then you add commits. And that's how you get to your final state, your code base. Another thing would be bank accounts or your account balance. It's very bad if your bank only holds your current balance in a table and that database crashes, right? That's not really how it works. Like, your balance is whatever salary you got in the beginning of the month, plus or minus every withdrawal that you did or payment that you did with your credit card. And if we start to look around in like the Java ecosystem and try to find out good matches for this kind of behavior or these characteristics, we'll soon find a library in Java. And could anybody guess what library that is with this clue? It's not the Skarsgård library. It's Actors. And Actors is a model of how you communicate, which was originally from Erlang, so from an Ericsson language. And in Java or on the JVM, this language is, or the implementation of the actor model is called Akka. And basically how Akka works is that it is a component which can hold state. This is our actor. And the only way that we can communicate with this actor is by sending it messages. Now what Akka does really, really well is concurrency. So it's thread safe, this actor, and like high speed and high load. So it's a concurrency library. And if we look at this and what we just talked about, it's pretty much the same, right? So what if our commands were these messages that we could send into our actor? And then our actor could actually be our aggregate, producing events and holding state. And if we look even further, more than just Akka, we'll find Lagom. And Lagom is a really good name for a reactive microservice framework. So we know what Lagom means, right? It's the right amount or just enough or the perfect amount. And this was released last year by Lightbend, the same company that develops and drives Akka forward. And what they aimed to do was to build non-blocking microservice systems with this framework. And it's very opinionated. It comes with very much opinions about how you should solve specific things. And what they choose as their opinion when it comes to handling with state was to use event sourcing. So we are going to have a look at some code as well, how you actually start to implement things in Lagom. So what we have here is our family of value commands, and this is usually how you start to model your model. So the interesting part here is the type, the value command. We can then start to implement this value command with our intentions. So the naming here is quite important. You see that we do an add value command, and we hold like an integer, the value that we want to add. And we could also do other commands which only gives us like the typing. That's what's important here. So this is to get the state. Now, as you saw before, like the commands should generate value or events. So we also have the corresponding interface for value events. This is our family of events. And we have a value added event, which is like the poor man's version of immutability. So we hold a final int value with only a getter. So what's important with when you look at this class is the naming. So this is something that happened. It's a fact in our system. And of course, that it should be immutable. And I know that there are better ways to do immutability in Java, but this is kind of to not confuse with too much code and annotations. Now, of course, we also want to build a state. And in our little web application, the state is very simple. We hold a number, which is our state. Now, to start to produce our first aggregate, which actually holds the state and which gives us a bit more purpose, we'll have a look at aggregates, which in Lagom are called entities, or a persistent entity. So a persistent entity takes in the types of commands it can accept, the kind of events it can emit, and the kind of state that it holds. Now this is a very simple example that I've done here today, but this can of course be like any Java object that you can build yourself. And when we start to implement these actors, what they expect from us is that we define a behavior, like how should this actor behave or this aggregate. So the first thing that you start to do is that you take a new behavior builder and you can give it a default value. So let's start at 0. Now, on this builder, we start to define how this builder or how this actor should behave on commands with a set command handler. So this could be an add value command, and we say whenever something of the type add value command comes into us, we get the specific instance of that command back and a context, which is something that Lagom provides to us. And something that is important when commands are sent to us is that we assert them, that we make sure that these are good guys. They are living up to our standard. For now, let's just make a null check for this command. What you then do is that you say context, then persist, a new value added event with the value that you got from the command. So now we say that this is the behavior that you should have whenever a command of the type add value command comes into us. And we of course also have to define a behavior of what we want to do when an event is emitted of the type value added event. What we want to do is that we take we create a new state, which is the previous state, plus the delta that this value added event held. And this is something we return. This is basically the minor implementation that you need to do to have an event-sourced actor. There are a few other cool things on this API. So we also have a set read-only command handler. So for instance, if you only want to get the state that this actor holds, it's not really like, you can just return. You don't need to emit any events. But there is also a set event handler changing behavior, which is really cool if you want to do something like a state machine. So you could say that you should start with this behavior that we defined until a special event happens, and then you should change behavior. Like in game development, this could be really useful. Now, before I got here, I cheated a bit, so I did a pre-implementation, which is basically what we just did together. It's just that it holds a bit of logging whenever a command is sent and an event is emitted. And let's see what kind of behaviors we get when we have this kind of system. So if we go from 2 to 3 to 4 in our state, and we have a look at what happened in our logs, we see that we got a command to add the value 1. That command emitted an event with the value 1. The previous state we had was 3, and the new state that we had was 4. And this gives a bit of interesting characteristics, because what happens if we crash the app? So when I click this bomb, I just crashed the app. And what you will see is that we will replay all the events. Remember, the only thing that we have persisted are the events. So we will start from our original state, 0. And then we apply all the events that ever happened to our state. So, why would you want to do this? One quite obvious thing is speed. And Akka is quite famous for really dealing with speed and scalability. But of course, we only persist like the deltas as well, right? So we don't really have any like locking different tables and doing transactions. So it is faster. It's in almost every case. And you could do this with like a write-only disk if you really are after really high speed. Something else that we get is the audit log. Like, it's quite common that you have to say to someone how you got to that state, and in RDBMSs we use something built into the product, or we build it ourselves on the side, and now we have two different like sources of truth to our database. But here, the audit log is our database. Like, how we build our log is by stating, or how we build our state is by stating every change that ever happened to our state. So it's like built in. The audit log and the database is the same. And these are kind of, yeah, speed, great, audit log, yeah, that's not that cool. But we'll start to see other benefits as well, which these behaviors can give us. And one of them is time travel. So I will show you this in something that's called Redux, which is pretty much the same principle, just in the front-end world. But this mirrors the state that we have in our backend. And since we always start from like an empty state, and then we apply all the events, what you realize soon is that we can start to jump in future. Like, what happened to our state? And we can replay and time travel in our application. So imagine that this application crashed when you reached 5. Well, replay all the state and all the events up to 4 and start to debug. And I think this is really, really cool. Like, this is cool stuff. And if you've seen bad Hollywood movies, you know what happens when you start to time travel, right? You try to start to change history. And with great power comes great responsibility. Don't do this, but it's of course possible. So if we say that all the events that we previously got, they are now worth 2. We should no longer interpret them as 1, we should interpret them as 2. So in our little application where we have 4, we now have 8. And whatever we now thumbs up or thumbs down is a +2. And it's not only that we change how we interpret them from now on, we changed the history. We changed how we interpret them 5 minutes ago. And as I said, this might not be a good idea. Most often I don't think it is a good idea. But something that's very interesting with this is that imagine that you have the data in the events, so as long as you like have the data there, 1 year after you implemented something, you can say that, hey, what if we interpreted this data in this way instead, in like another branch? You could come up with new use cases and apply them whenever you want, as long as the data is there for interpretation. So did you get that difference? Like, it's really cool because you can interpret the data in new light, but I wouldn't suggest that you start to change like already interpreted data. Cool, right? Yeah? Yeah, a few nodding heads. When you start to model your data and how you persist things this way, you will also, or something that has come up is a process that is called event storming. And this is more of like the soft side of how you design your applications. So today, oftentimes when I go into a team room with my team and we start to discuss about like, okay, what entities should exist, what's the relation between them, should this own that or that? Well, when you design systems like this, start to think about what events can occur in our system and how does these events affect our state. And in this way, you could start to drive a more domain-driven design, where the domain is in focus, like what happens to our system. And this is, of course, something that you can do even if you don't use event sourcing. I think it's a really good practice or experience to have with your team. But when you do it with event sourcing, basically your domain processing and your architect, it's the same person, or you do the same thing, right? So yeah, that's cool. We can like be really fast on writing events, and we can travel in time on those events, and we can change history, and yeah, everything is good. But what about the read side? Like, we don't really want to go into the database and start to query all of these different deltas. Like, that usually doesn't make much sense, and it could be quite hard to even get anything good out from them. And usually when you start to read about EventSourced system, you also find out about cycles, which is the most stupid buzzword out there. And I know that it stands for Command Query Responsibility Segregation, and that's a really complicated way of saying separate your write from your read side. So if you have the write side where we emit our events and we save them down into our database, and we can replay them from this database and keep on amending into this amend-only database, well, we can of course start to subscribe to these events from other databases or other data storages. And this read database, that could be an Elasticsearch database if you're out after indexing or searching. It could be a Mongo database or a MySQL database. And these can be designed for the purpose. So you don't really have to make amends between the write and the read side and what is good and what is not. You can make the read side optimized and prepared for the use cases that you want. Because it's quite different to have an Elasticsearch database and what that solves from maybe a Mongo database. And of course, this doesn't come for free. Like, it looks nice in a PowerPoint or on a picture. But what you find out is that everything doesn't happen immediately. There's no transactions. You subscribe to this afterwards. And that means that you are now in an eventual consistent system. At least if you want to write this with asynchronous messaging and have really high speed, then you will have to do this asynchronously. And when I first read about this and eventual consistency, I like my transactions. I like when my data is consistent. I like all of these things that we've learned to love, right? But then eventual consistency isn't that bad. It's a necessarily evil if you want to write really high scalable systems. And this is actually how the world works, right? Like, when I buy a chocolate in the store, there's no thing such as a transaction. Basically, transactions is something that we invented as developers. It's not like I'm standing there with my money and the cashier with the chocolate and we say, on 3, let's go. That's not how the world works. She gives me the chocolate and I give her the money. Eventually we will have had a consistent state. If I forget my girlfriend's birthday and she gets angry, I don't travel back in time and make up, change history. I make up for it later on, and eventually she's happy again. Hopefully. I would never forget your birthday, Emily, if you watch this on YouTube later. So, eventual consistency, it's like a necessary evil, and it's something that we have to take room for if we start to build these kind of systems. And if we are working in a microservice system, we are already eventually consistent. There's no such thing as a two-phase commit in a microservice system. You don't call every microservice and say, on 3, let's all just push this thing into our database. So if you do this with events instead, and if you start to look at on a system-wide aspect, you could start to produce these events on things like Kafka, which, by the way, Lagom comes bundled with. So you could put an event on the Kafka queue, and whoever in your system wants to consume it could consume it. And again, since we have the asynchronous behavior in microservice systems, you could gain a lot of speed since you already bought into the eventual consistency. Okay. That's pretty much what I had today. So now I tell you that forget about RDBMSs. We have the silver bullet. And no, of course we don't. You've seen touched on the top of the iceberg, and this This gives some benefits. It gives some really, really interesting characteristics. At least I think so. But really try to think like, will this apply to our team or will this apply to us? Would we get the benefits? Because if you don't get the benefits, we are far more experienced with RDBMSs. We are used to the APIs and we are used to like the data model and having our data consistent. But if you start to scratch on the surface, you will find that, yeah, okay, maybe this applies to this situation. And in a big system, of course, a part of your system can be event-sourced, where it makes sense. Okay, if you want to find these slides, I will upload them to widr.se/slides. If you want to have a look at like the code, you could go and clone this from my GitHub, which is on widr.se/code. And you just write maven lagom :run all. They have extremely good development support. And if you find the slides, you can look at these references as well. Okay. Do we have any questions? Yeah. You would absolutely get a performance issue if you had millions and millions of events. What I didn't show you here is that there is a mechanism which is called snapshot, which basically says that once every 1,000, or it's a configurable, but let's say once every 1,000 events, let's take a snapshot of the state. So what I didn't tell you, you see this initial behavior that we have. We get a snapshot state, and either we start from that, or we start from like our very, very, very default state. So in the case if you have 1,005 events, you would start on 1,000 and apply the 5 ones. Yeah, so it's a really good question. And then, yeah, maybe I didn't say it. The question was about what if you get 1 million events or have to replay everything all the time. Okay, there doesn't seem to be that many questions. I have one thing that I want to ask of you guys here. On widr.se/survey, I've made a small survey where you can rate this talk from 1 to 6. Please at least go in and give it a number, the presentation. There is also a text box which is completely optional, but if you feel like you want to give me some input, especially if you think it was a bad talk, please give me some input on how this could be improved. Final call for questions. Yep. So the question was, what if you have something that changes over time, or where you... sorry? Yeah, if it's happy hour or not happy hour. If it's happy hour or not happy hour, that's part of your domain. Like that's part of your business model, the logic in your system. So you would have to, in the events, if, like just from the top of my head, give the information of when the event was emitted. But that's has really nothing to do with the like the technology. It's more about your domain, your business case in that case. Yeah. Yeah. So if your application is time critical, you have to build in a timestamp into your events that are emitted, or even your commands, and then make the educated decision based on that. Absolutely. And this, in the end, it comes to how you model your events. What information do you need to retract from the events? Yeah, potentially. Okay, good. Yeah, so there is something. So the question was, what if an event emits an event and they fail basically? So what I told you about the commands was that it's very important that you validate them because they are intentions. And if you do something like an event emitting an event, you are in for troubles. So The reason why we separate commands from events is that, of course, we could take the commands and push them down into the database. That's actually something that's called command sourcing. But the event should be facts that has happened, while commands are intentions. So yeah, if you do that, don't do it. Like, try to rethink it. What happens in our system? Maybe this event makes a new command being registered, and then you are like in your thread safe context again. But never persist something until you have like validated it, because that will be replayed every time your like aggregate is rebuilt. And if you have corrupt data in events, oh boy, that's like rough. So that's basically why you separate commands from events. Commands are steering signals, intentions. Events, they have happened to your system. That's how you should look at it. So also that's why it's important that events are immutable. You never go in and start to like fiddle with the state. Okay, with that said, please go in and rate this talk, and find me at GoToOla at Twitter if there are more questions. And thank you.